Let's talk about how we write and balance chemical equations. But I want you to really focus on that word equation. You already know from the law of conservation of matter that in a chemical reaction, we do not destroy or create matter. We just take the substances that were there before the reaction, which we call the reactants, we break those chemical bonds, rearrange the existing matter, and make new substances that we call the products. So let's quickly look at the components of a chemical equation. The reactants are the substances that are there prior to the reaction, and the products are the things that you generate in the reaction from the reactants. We put the reactants on the left side of the chemical equation and the products on the right side of the chemical equation. When you have multiple substances on either the reactant or product side, you separate those substances with a plus sign. And arrows are used to separate the reactant and product sides of the equation. Often, balanced chemical equations will require that you have more than one of a particular substance. For example, in our reaction here, we need 2 oxygen molecules to be able to react with that methane gas, which will produce 1 carbon dioxide and 2 water molecules. We represent this in the balanced chemical equation by putting a coefficient in front of the chemical formula for any substance that you need more than one of. And this is why it's called a chemical equation, because the 2 halves of the reaction are equal to each other in matter. We begin with 1 carbon atom, 4 hydrogen atoms, and 4 oxygen atoms, and all we do is rearrange those atoms to form new substances, but we still have 1 carbon atom, 4 hydrogen atoms, and 4 oxygen atoms. Lastly, the physical state of matter of each of these reactants and products will eventually be very important. But for now, let's just get used to writing them down. There are 4 common states of matter that you're going to write on a balanced chemical equation. Solid, liquid, and gas, using an S, L, and G, are probably states of matter that you're very familiar with, but aqueous is likely new. You know what solid salt looks like. And you can actually get liquid salt, but you have to heat it incredibly high, and we call that molten salt. But when I take salt and dissolve it in water, it is no longer truly a solid, but it's also in no way a liquid. What it is aqueous salt ions that are dissolved in water. This is a new phase of matter that we will discuss in more detail in the future, but I just need you to understand that it is not solid, nor is it a liquid. It is ions dissolved in water. Well, now here we have some word equations, and I want you to go ahead and write the balanced chemical equation. I'm going to do the first one with you. Nitrogen and oxygen gas combine to form a molecular gaseous compound called dinitrogen pentoxide. First, we want to identify the reactants in the reaction and the products in the reaction. Next, we write down the chemical formulas for both the reactants and the products without worrying about balancing just yet. Now, clearly we can see that what I have written here is not balanced, and it appears like somehow 2 oxygens magically became 5 oxygens. As tempting as it may be, we cannot change these subscripts to balance the equation because these are the true chemical formulas for these compounds. Instead, we add coefficients in front of the chemical formulas to balance the matter. By adding a 5 in front of the oxygen gas, I now have 10 oxygen atoms on the reactant side. And by adding a 2 in front of the dinitrogen pentoxide, I now also have 10 oxygens on the product side. Therefore, my oxygens are balanced. And now by simply adding a 2 in front of the nitrogen on the reactant side, I have 4 nitrogen on the reactant side and 4 nitrogen on the product side, and all my matter is balanced. Pause the video now and give the next few problems a try on your own. When you think you've got it, push play and you'll see the answers. So in this next reaction, we have aluminum plus oxygen makes aluminum oxide. Aluminum is a +3 ion, oxygen is a -2 ion, so the chemical formula for aluminum oxide is Al2O3. Again, the matter does not seem to be balanced because it's not. However, once you add the coefficients, you can see that you have 4 aluminum on the reactant side and 4 aluminum on the product side, and 6 oxygen on the reactant side and 6 oxygen on the product side. Now pause the video and check out these reactions. If you don't have the same coefficients, it's likely because you wrote your nomenclature wrong. So check it out, and if you don't know why the chemical formula is what it is, make sure you speak to me. Now try these 3 and I'll show you the answers in a moment. And here are the solutions. Again, if your coefficients don't match mine, it's likely because your chemical formulas do not match mine. Nomenclature is not going away for the rest of the year, so we have to get really good at it right now. I'll walk you through reaction 10 so you can get the whole process one more time. We identify the reactants first. Copper is an element and it's not diatomic, so we just write copper down. Silver nitrate is an ionic compound, silver being a 1+ charge, nitrate being NO3 with a -1 charge. It's one of your common polyatomic ions. In this particular reaction, the copper replaces the silver, meaning it kicks it out of the compound and takes its place. And we see we form copper nitrate, copper 2 nitrate specifically, where the copper has a 2+ charge and the nitrate still has a 1- charge. So that's Cu, and then in parentheses, NO3, that nitrate, we need 2 of them. And then the silver is by itself. Now if you look here, this is not balanced. So we add coefficients to balance the matter. And that gives us our final answer right here. Try these last two one more time, and then I'll show you the answers. Pause now. And here are the answers to the last two. Couple bits of nuance. First of all, remember, whenever you have a diatomic element as a lone element, not as part of a compound, but as a lone element in a chemical equation, it should have a subscript of 2. Right? Also, if you look at this fluorine in reaction 12, it starts as F2 because it is a lone diatomic element, but then becomes F3 because in order to properly form aluminum fluoride, the ratio is for every 1 aluminum with its 3+ charge, I need 3 fluorides with their 1- charge. You must always have the correct formula first, then worry about adding in your coefficients to balance. If you do not have the same coefficients that I have, it is likely because you did not properly write the chemical formula.